Hey, hello and welcome to today's GFG problem that you're uploading well. So let's say today's problem, two sum pair with given sum. Okay, so what the problem is saying is we'll be given an array of positive integers and another integer target. Okay, so we want to determine if there exist two distinct indices such that the sum of their elements is equal to target. Okay, so in this case, for example, we are given an array, okay, and we are given a target, okay. So we want to find out whether there exist two elements, right, two elements whose sum is equal to the given target. For example, which are those two elements? Those are 6 and 10. Okay, 6 and 10, 6 plus 10 is equal to 16. Okay, now the question is how we are going to find out those two elements. Okay, so first of all, let's see one naive approach. Okay, one naive approach. It's not a naive approach, it's one of the better approaches. Okay, it's one of the better approaches, but not the expected one. Okay, so let's quickly so what we can do is we can sort the array first of all. Okay, we can sort the array. So how the sorted array will look like? 1 4 6 8 10 and 45. Okay, so this is the array, which looks like this is our array after sorting. Okay, now what we are going to do is we are going to run we are going to run um, a two pointer approach. Okay, we are going to have L and R. Okay, for example, L and R. Okay, and what we are going to do is we are going to run a while loop. Okay, while L is less than R. Okay, and we're going to check if L plus R, if element at L plus R, R of L plus R of R. Okay, let's take into sum equal to R of L plus R of R. Okay, if sum is equal to target, if sum equal to target, okay, then simply return true. Okay, then simply return true. Okay, if sum is less than target, if sum is less than target, that means that means we should increase our L. Okay, we should increase our L because in order to increase the sum. For example, let's quickly see what I'm trying to say here is, okay. Okay, so here 1 plus L is pointing at this one and R is pointing at 45, right? So 1 plus 45, which is 46, and which is greater than 16, the target, which is greater than 16, the target, right? So in this case, what we want to do is we'll come to else part. Okay, because sum is greater than target, right? We'll come to else part wherein we'll decrement our R, because the sum is greater than target. Okay, so we'll have to reduce the sum. So when we can reduce the sum? When we reduce our R. Okay, so R, because it is sorted, right? So now we will update our R. Okay, now we are going to calculate 1 plus 10, we are going to say, right? 1 plus 10. L is pointing at 1, R is pointing at 10. So 1 plus 10 is 11, which is less than the target 16. Okay, so this condition will be executed, sum is less than target. Okay, so we are going to increment L. Why? Because we want, why we are incrementing L? Because we want to increase our sum, right? We want to increase our sum. Okay, and increasing the L, right? Incrementing the L pointer will give us the bigger element. Okay, so we'll update our L pointer. L will point here. Now 4 plus 10, right? 4 plus 10 is what? Will give us 14. Okay, again it is less than target. So we want to increment this sum, this particular sum, right? So we'll, by increasing L, we'll get a bigger element at L, and hence the target will be increased. So we will increment our L. Okay, now L plus R. What is L? L is pointing at 6, R is pointing at 10, which is now 16. Okay, so this matches our target. So this condition will be executed. This if condition will be executed where sum is matching the target, and hence we are going to return true from here. Okay, so this is the happy scenario. Now, for example, if the target was something 17, right? Now there is no such two elements wherein the target would be 17. So L will go ahead and go ahead of our pointer, and hence the while loop will break, and we are going to return false here. Will return false here. Okay, okay, okay. Now this approach, we can say it's a better approach, but here the time complexity is going to be O of n log n, right? O of n log n, and space complexity, it is going to be O of 1. Okay, now can we reduce this time complexity? Okay, is there any approach wherein this time complexity can be reduced? Yes, there is an approach, and we are going to discuss that. Okay, we're going to discuss that. Okay, so let me erase the screen. Okay, now let's see the expected approach. Okay, the expected approach would be, we'll take a hash set. Okay, we'll take a hash set. Okay, now let me represent the hash set using this. I mean, it looks like stack, but it's not a stack. Okay, it's a hash set. Okay, so what we're going to do here is we are going to start iterating the element. Okay, we are going to start iterating the element, and we are going to find out the difference between target which is 16 minus air of I, let's say. Okay, air of I, and let's say the difference, we can say the difference. Okay, difference 16 minus 1, which gives us 15. Okay, so we're going to check this whether this difference 15 is it part of hash set. No, it is not part of hash set. Okay, it is not part of hash set. So what we're going to do, we are going to add this element 1 into this hash set, and we are going to move ahead. Okay, we are going to move ahead. Next, we are going to we will deduct 4 from 16. Now our pointer is pointing at 4. 4 from 16, diff is what? 12. Okay, we're going to check in this hash set, is it present? No, it is not present. So we're going to add this 4 into our hash set, and we'll move ahead. Okay, now we have 45, 16 minus 45 we are going to do, which will be a negative number. Okay, which will be a negative number. Okay, which is not equal to, okay, the negative number, for example 16 minus 45, whatever it is, right? Whatever some negative number, right? Maybe something 30, no, 45, 35, 35, 29 minus 29. We're going to check if the hash set is it present. No, it is not present. We are going to push this 45 into this hash set, and we are going to move ahead. Okay, we're going to move ahead. Okay, now what are we going to do? We are going to deduct 16 minus 6. Okay, our pointer is pointing at 6. 16 minus 6, which is 10. Okay, we're going to check this 10 into this hash set. Is it present? No, it is not present. So what we're going to do, we're going to add 6 here, right? And we're going to move ahead. Okay, we're going to move ahead. Now our pointer is pointing at 10. What are we going to do? We're going to deduct 10 from 16, right? Which will give us 6. Now we are going to check this 6 into this hash set, right? Which is present in this hash set, and hence we can say that we have found those two elements, and we are going to return true from there. Okay, we are going to return true from there. If there's no such element, then we're going to return false. Okay, so this is the intuition behind solving the problem. Okay, now let's go and code. Okay, with coding you'll understand better. Just one request to please, I've tried to make it very easy for you, so please subscribe to the channel, like the video. Okay, let's quickly code this. Okay, and we'll also discuss the time complexity and space complexity as well. Okay, so here, what we're going to do, as discussed, we're going to take a set. So I'll show the Java code followed by C++, set equal to new hash set. Okay. Okay, now what are we going to do? We're going to num add, and we are going to take the diff equal to target minus num, and we're going to check in this difference. Okay, if it is if the set contains this diff, that means we have found the two elements. We're going to return true. If the set does not contain, then we're going to add the current number into the set. Okay, which is num. Okay, and finally, if we didn't find the element, right? If we didn't return true from here, that means there are no two elements. Okay, whose sum equals to the target. Okay, so we are going to return false here. That's it. So let me compile this. We'll discuss the time complexity as well. I mean, you can figure out. Let's submit this. Okay, so the time complexity here is O of n. Okay, as we are iterating the array only once. Okay, it's O of n, but only the space complexity again will be O of n. Okay, we are taking extra space, but this is the expected approach. Okay, this is the expected approach. Okay, thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. So here's the C++ code. Here we have taken another set. Okay, and then we are taking the difference. We are finding in the set. If we find the set, that means we found the two elements. We'll return true from here. Else we'll return the current number to the set. Okay, and if we don't find the two numbers, we're going to return false at the end. Okay, so thanks for watching. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much. Thank you.